All right, let's dive into a massive question in the world of AI. How do we take our most powerful AI agents and make them not just smarter, but way faster and more efficient?
Because that's the real problem, isn't it? You give an agent access to all these incredible tools, and suddenly it gets, well, slow and expensive. It's this weird paradox where the more capable we try to make them, the more clumsy they seem to get. So what is actually going on here?
Well, it turns out the problem is a kind of hidden bottleneck, a really fundamental limit on how these agents actually think. And it all comes down to the agent's workspace, or what we call the context window.
To really get the problem, you first have to get the standard. The Model Context Protocol, or MCP, is basically the universal language that lets an agent talk to everything else online. Think of it like a USB port for AI. It lets a single agent plug into thousands of different tools, from your Google Drive to Salesforce, without needing a custom hookup for every single one. It's awesome, but it also creates a brand new kind of traffic jam. So, here's the best way to picture it. An AI agent's context window, it's like a tiny workbench. And every single thing it needs to think about, your instructions, the tools it has, the data it's using, it all has to fit on this one little surface. And you can probably guess what happens if that bench gets too cluttered. Everything just grinds to a halt. So, how does this workbench get so ridiculously messy? It's really two big things. First, what you could call tool manuals. Every time the agent starts a task, it has to load the instruction manual for every single tool it's connected to, even if it only plans on using one of them. It's like having to read the entire IKEA catalog just to find one little screw. And then there's the clutter. Every piece of data the agent handles has to be physically placed on the workbench, even if it's just passing it from one tool straight to another.
And here is a perfect real-world example of this. Let's say you ask an agent to grab a meeting transcript from Google Drive and add it to a Salesforce record. Simple enough, right? Well, the agent first calls Google Drive and plops the entire transcript onto its little workbench. Then it calls Salesforce and has to copy that entire transcript, word for word, from its workbench into the next command. That one piece of data just ate up your expensive context window space twice. It's just wildly inefficient.
So how do we fix this mess? The solution isn't some crazy new technology. It's actually a really elegant, simple change in how we think about the problem. Instead of having the agent hold all the tools, what if we just gave it a pen and paper and let it write down the plan?
And here it is. This is the big aha moment. We let the agent stop being a manual laborer and let it become a programmer. Instead of calling tools one by one, the agent just writes a tiny bit of code that tells the tools how to work together directly.
See, this is the old way. The agent is a middleman. It calls Google Drive, the full transcript comes into its context, and then it calls Salesforce, passing that same transcript back out. The data has to flow through the agent. But now, with code execution, the agent's job totally changes. It just writes this simple little script. The script tells the Google Drive tool to hand the transcript directly to the Salesforce tool. That huge chunk of text, it never even gets near the agent's workbench. The agent just becomes the manager, not the one doing all the heavy lifting.
And the result of this one little change? 98.7%. Seriously, that's not a typo. For that one simple task of moving a file, this approach cuts down the tokens used and therefore the cost and the time by almost 99%. It's just a completely staggering improvement. This simple switch really does kick off a full-blown efficiency revolution. It lets the agent handle data in much smarter ways and do so much more with so much less. And this gets even more powerful when you're dealing with big data. Like, imagine asking an agent to find a few pending orders in a spreadsheet with 10,000 rows. The old way, it would have to load all 10,000 of those rows onto its workbench just to look through them. But the new way, it just writes a tiny script to filter the data before it ever sees it. All the agent ever has to look at are the 5 rows that actually matter.
And it gets even better. Because the agent is writing code, it can now use basic programming logic. Say you need it to wait for a specific Slack message. Instead of constantly bothering the main AI model asking, "Is it there yet? Is it there yet?" the agent can just write a simple loop to check on its own every 5 seconds. It's the difference between an impatient kid in the back seat and a patient, efficient professional.
So these efficiencies don't just make the agent faster, they actually unlock brand new abilities. It's like the agent gets a promotion, going from a simple assistant to a true architect that can design complex workflows. First up, a huge one:
security. With code execution, we can build a really powerful privacy shield. So when an agent writes code to move, say, sensitive customer data, a little client program can automatically jump in, swap out the real emails and phone numbers for generic placeholders, and then show the code to the AI model. The real private data goes straight from point A to point B, but the AI model itself never, ever sees it. This is a massive win for security.
The next superpower is memory. You know, normally AI agents have amnesia. They finish a task and poof, they forget everything. But code execution gives them a way to actually remember.
Here's how it works. First, they can save their work. If they're in the middle of a big multi-step job, an agent can just write its progress to a file like leads.csv and then pick up right where it left off later. But what's even cooler is that it can save the code it writes as a brand new reusable skill. So if it figures out a really clever way to convert a spreadsheet, it can save that script and use its own custom-built tool forever. This is how agents actually start to learn and evolve over time.
Okay, this all sounds pretty incredible, right? But it's important to be realistic here. This kind of power doesn't just come for free. There are some really important trade-offs you have to think about.
On the one hand, the benefits are obvious. You save a ton of money, things run way faster, and you get these amazing new abilities like privacy and memory. But the cost is added complexity. If you're going to run code that an AI generates, you absolutely need a secure, lockdown environment, a sandbox, so it can't cause any trouble. It just means there's more setup and new security stuff to think about.
And that really brings us to the biggest takeaway here. This quote from the source material just says it all perfectly. While all these AI problems like managing context and state feel brand new and cutting edge, the solutions are actually rooted in decades of classic, proven software engineering. We're solving the problems of the future with the wisdom of the past.
Which leaves us with one last, pretty mind-bending question to chew on. We've just seen how agents can go from just using tools to actually programming them. So, what's the next logical step in that evolution? If today's agents can write code to use tools, will tomorrow's agents write the code to build their own?